Recording. So today we are talking about rational functions, okay? For 25:17. So rational means fractions. We've been talking about fractions, right? I can't see this. Sorry, Josie. So rational functions, and again, when we talk about the word rational, we're talking about fractions, okay? So the very first example I have up here, in fact I have it underlined, but I'm going to highlight, okay? Vertical asymptotes is where the function divides by 0 and can't be removed. So if I look at my example, I can't remove the 3. You guys agree? Cannot remove this x plus 3, okay? So I already know on this one I'm going to have a vertical asymptote at -3, okay? And a whole is where when you divide by 0, it can be removed. So before I do anything, let's identify the problem. So to identify the problems, first of all, x cannot equal 2 and x cannot equal -3. Okay, right off the bat. I don't care what's on the top. 0 on the top is okay. 0 on the top is 0. 0 on the top is 0. 0 on the bottom is bad. 0 on the bottom is either you kick your asymptote or send you through a hole. Okay? Got it? Okay. So now right off the bat, can't be 2 because 2 minus 2 is 0. Can't be -3. Because -3 plus 3 is 0, okay? Got that so far. Now, the problem is that one of these is removable. So if I were to cross off x minus 2, that means the problem was removable. This problem is removable. If it's removable, that's my whole. So my whole is at x equals 2, but I can't get rid of the x plus 3. So the -3 is a problem that can't be removed, so that's a vertical asymptote. So my vertical asymptote is at x equals -3. Now, when I do a vertical asymptote, it's really not part of the graph, it's a boundary line. So I put it as dashed, straight up and down. So when I graph this, I do know, and Jackson's calculator actually put it in for me. 1, 2, 3, I'm going to go ahead and do dot, 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 dot. It is not part of the graph, it's just a boundary line, okay? So when we graphed this thing, we saw some things, but I have a hole at 2. So at 1, 2, I have a hole, but where is the hole? It's there. I mean, if I take a look at my calculator, sure enough, it's there. It's part of the graph. You guys see it? I can go to my trace button, and it's right around there. So exactly where it is. Well, listen. You cannot plug 2 in because you'll divide by 0. But after you get rid of the problem, and it just becomes x plus 1 over x plus 3, and I cancel it out, I can plug 2 in, can't I? Right? After I get rid of the problem, get rid of it, I can plug 2 in. So if I plug 2 in, I get 2 plus 1 over 2 plus 3, which is 3 over 5. So the whole is at 2, 3/5. That's where the location of the hole is at. Okay? So I'm going to go and put a hole, and I want you to draw it like that. Now, granted, I know that technically the hole is this thick. It is. But we're going to draw it big so we can see it. Got it? Does that make sense? Because technically the hole is really this thick, but it's there. But let's draw it like that, okay? So then we saw from my calculator, it looks like this, okay? Now there's a horizontal asymptote also at 1. Somebody's going to say, how did you know that, Mr. Davies? Okay, so let's go at 1. Let's put that in. I'm going to show you how I got that one. Okay, now the graph is going to look something like this. Okay, it's going to go through, and it's going to look, here's what my graph looks like. Something like this, and something like that. Okay, I've got my hole, I have my vertical asymptote, and I have my horizontal asymptote. Now, you don't know where I got my horizontal asymptote from, do you? But I'm going to teach you that too, okay? But hold on to that one. How did I get this? We're going to go to infinity, but not right now, okay? Okay, now first of all, graph example 2. Graph y equals 1 over x. Well, 1 over x actually looks like this. Okay, it looks like this, and like this. And its asymptotes are here and here. Okay, it's the same graph that we just put, but it looks like that, okay? That's what we call our parent function. This is our parent function. Because most of our graphs will look like that. In fact, this one looked like that too, didn't it? Okay. So when you're doing rational functions, these fractional ones, most of them will look something like this. Okay. Can't divide by 0. You usually have a problem. So there's our problem. Okay. So then, if I want to graph example 2, let's take this shape and put it down here. Okay. Let's take this shape and put it down here. Okay. So first of all, we talked about moving things, right? We talked about moving the vertex before. But what we're going to do is take it. We're going to move it back 2. Remember doing the opposite? So let's take our asymptotes. We're going to move our asymptotes. So move asymptotes. So we want to move this graph here. This graph right here. We're going to put over here. We're going to take the whole thing and move it back 2. So let's take our asymptotes and move them back. Boom, 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 boom. And boom, 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 boom. Yeah, okay, there you go. Can you see the thing? So I'm taking this graph and I just bumped the whole thing over 2. That's all I did. Because we always go the opposite, right? Opposite inside. So I took it opposite back and forth. So I took the whole thing and moved it over back 2. Okay, that's easy, right? And let's just draw it in. It doesn't have to be perfect. We don't have to have a perfect graph yet. We just need the right shape, okay? I just need the right shape. That's the shape, okay? All I want you to know is what a rational function looks like today. They look like this, okay? So example 4, let's move this one. We're going to move this graph. We're going to go and move it forward 3, and we're going to go up 2, because we're going to go the opposite of that. So we're going to go forward 3, and then up 2, okay? So let's take this graph here, and we're going to move it forward 3. So let's take the asymptotes. We're going to go over 1, 2, 3, and then up 2. We're going to graph it in. Alright, thumbs up, sideways, we're okay so far? We can do this. Now let me ask you a really easy question, which is not on my graph, but it's going to be on your homework. What if it was negative? What if this was negative? What would you do? Just guess. If this were a negative one, put it upside down, right? You just tip it upside down. I just take this whole thing here, and I go like that. So this would be down here, and that'd be up there. Does that make sense? If it's negative, it just goes, right? Okay. All right, turn the page. Let's keep talking about holes and asymptotes. Yes, Sarah.
Top one was opposite, but it wasn't negative.
Right, if the top one was negative, oh, this one here would be the same way. It would be flipped up so that this part would come up.
It's not negative. Why is it opposite?
We're going to see that later. Okay, hold on. I'm going to teach that one later. No, very good question. We're going to see that one later. It has many more terms. That's why. Part of it has many more terms than just 1 over, okay? Okay. Turn the page. Okay, here it is. Okay, let's see. Before I even do anything on this problem, before I do anything, tell me, please tell me, what can't x be?
2.
X can't be 2. X cannot be 2. So before I do anything on these, the first thing I identify is the problem. It's kind of like the problem child, okay? Right off the bat, x cannot be 2. Because if x is 2, 2 minus 2 is 0. We're in bad shape, right? So now, let's see if we can factor the top. See if it makes any difference. So if I factor the top, I'm going to go x minus 3, x plus 1 over x minus 2. Okay? Can I remove the problem?
No.
So, 2 is an asymptote. I'll say it again. Can you remove the problem? No. So this is an asymptote, not a hole. So I'm like, okay, I can do that. So I go to 1, 2. So I go to 1, 2, and put in my asymptote, okay? There you go. Thank you, Josie. Okay. So at 2, 2 is a problem. If I can't get rid of it, then it's an asymptote, okay? A vertical asymptote, okay? Now, what else do I know? Well, 0 on the top is 0. 0 on the top is 0. Do you believe me? I mean, 0 divided by 5, 0. 0 divided by 10, 0. 0 by 10 pink elephants, 0. 0 divided by 10 wills, 0. 0 divided by Jonna, 0. 0 on the top is 0. So, you what? Guess what? At x equals 3, we have a 0. We have a 0. At x equals negative 1, we have a 0. How's that? That makes sense. 0 on top of 0. So let's graph it. See what it looks like. Okay, so to graph it, go y equals, let's put it in my window, y equals, clear that. Now I will use, like Jackson said in his sleep, I'm going to use parentheses, right? Got to use parentheses because I need my entire top divided by my entire bottom. So I'm going to go parentheses. I'm going to go x squared, subtract 2x, subtract 3, divided by parentheses. I'm going to go x, subtract 2, graph it. Okay. My asymptote's invisible, isn't it? Did anybody's calculator graph it? Yours did? Okay. Can I see yours, Sarah? Okay. Oh, yours did. Okay. So the asymptote is not part of the calculator, right? It's not part of the graph at all. It should be invisible because it's not part of the graph, and mine doesn't show it, right? Sarah's calculator freaked out. Check it out. It freaked out. Do you know why it freaked out, Sarah? Because you tried to divide by 0. It kicked its asymptote, didn't it? Right? They don't exist. The asymptotes are not part of the graph. They really aren't. It really should look like this. But it goes to prove that it didn't like it, did it? It did not like divided by 0. So we've got a picture of it. And guess what? It's going to go through. It does go through here, doesn't it? And it goes through here. And there's my graph. So the zeros, identify the zeros. That's easy. The zeros, well, that's at 3, 0, and at negative 1, 0. My asymptote, that's at x equals 2, right? And the holes, none. There are no holes, right? There are no holes. Okay, last one. Kind of getting the idea? It's not too bad. Kind of getting the idea? If you can get rid of it, remove it. It's a hole. If you can't get rid of it, kicks your asymptote, okay? Last one. Let's check out the last one, okay? Let's go ahead and factor. So before I do anything, let's factor x plus 2, x plus 3 over x plus 2, x minus 2, okay? Okay, start there. Number one question, what can x not be?
Negative 2.
There you go. X cannot be negative 2, and x cannot be 2. Can't be either one of them, right? If it's 2, you divide by 0 right here, you get 2 minus 2, bad news, divide by 0, bad, okay? It's negative 2 plus 2, bad news, divide by 0, okay? So have I convinced you don't divide by 0?
Yes.
Bad things happen, okay? Really? So which one is which? Well, I think that I could remove, whoops, I can't remove that one. I went the wrong way, whoops. Do I have an eraser handy? Darn it, good thing I did an eraser. Come on, here's an eraser, there we go. Start again. All right, how about that? There we go. Gone, right? So that tells me at x equals negative 2, so I have a hole, because it's removable, at x equals negative 2. I've got a hole, right? I got rid of that. So if I can get rid of this one, the negative 2 problem, I got rid of the negative 2 problem, hole. But I can't get rid of this problem, right? So I'll have an asymptote. Yeah, at x equals 2. So I'm just going to put that in there, okay? Slide over, go 1, 2. That's not a very good looking asymptote, but there it is, okay? It's an invisible line. It's a boundary line. That's all it is, right? So then I have a hole. Now I'd like to know exactly where the hole is. So once I cancel that out, right? Then I'm left with just x plus 3 over x minus 2, right? And I could plug in negative 2. I really could. I could plug in negative 2. Let's plug negative 2 in there, negative 2. So I just plug my negative 2 in. So I can say, okay, I can do this. I can do, okay. I say, okay, negative 2 plus 3 over negative 2 minus 2 makes negative 1/4. I'll let you think about that, negative 1/4. I will. Okay, so my hole has a coordinate. It's at negative 2 comma negative 1/4. All right, so negative 2, negative 1/4 might be right about there. So I'll put my little hole there, okay? That's where my hole is, about negative 2, negative 1/4, okay? Now, let's take a look at it, right? Let's graph it and see what it looks like, okay? Graph, y equals, clear that one, let's put this one in, so I'll go parentheses, right? X squared plus 5x plus 6, parentheses divided by parentheses, x squared, subtract 4, and I graph it, and okay, it freaked out. Okay, you can see where it freaked out. Freaked out right there, didn't it? Freaked out right there. So, I mean, obviously, something weird's happening here, and we know what it is. It is an asymptote. Even though it didn't show it, you have an asymptote there, okay? Now, what else we have? Okay, we got a hole, right? So, where's my hole? So, let's check it out. Let's go trace. Yeah, I sure will. I can't actually zoom out, but I'll put it here. Trace, negative 2, enter. Boom. So, Stubbs, you'll love this, okay? You'll love this, won't you? No, you'll love this, okay? So, what happens when you divide by 0, guys? Tell them, man.
Bad things happen.
Bad things happen, so tell me.
Cookie monsters.
Cookie monsters happen. What else? What happens? What 2 things can happen?
Can you get your asymptote?
Either you get your asymptote kicked, or you fall in a hole, right? There you go. And he totally gets it, right? So, if it's removable, it's a hole. If it's non-removable, it's going to kick your asymptote, okay? All right, there you go.